Hello class, this is the last two examples on double angle identities. You can go ahead and pause the video and give this a go yourself. Now, let me just bring this down so I'm not scrolling back up and down. Now, it may not seem so obvious how to solve this, but I'll demonstrate to you what we can do. So take a look. It seems as if that we don't have a double angle, do we? However, half of x is kind of similar to a double. Okay, so what we can do here is if we let u equal x over 2, how do we get x? Well, if we do 2 times u, that gives us x. Well, that's exactly what we're going to be doing. So take a look. Since we have x here, we're going to make that 2u. So cos of 2u plus 2 cos of u equals 3. And that there is what we're going to be using. Now from here, cos 2u, we can apply the double angle identity once again. So, let's bring this over. You can give this a go. Let's try and expand this ourselves. So cos 2a becomes cos squared u minus sine squared u plus 2 cos u. Just to predict this for later, because it's easier if we let everything equal 0 and just factor from there. So I'm going to move move the 3 to make it negative, and we're left with this equation here. As we saw previously, we can change sine squared into something in terms of cosine. If you don't recall, sine squared x is equal to 1 minus sine squared, not sine squared, cosine. By substituting that, we get cos 2u minus, well, and this is going to be u instead, minus 1 minus cos squared u plus 2 cos u minus 3 is equal to 0. Gathering like terms, minus with minus, it's going to be negative 1. Minus with minus, that's plus cos squared u. So that expansion, we're going to add to the rest. Cos squared u plus cos squared u is 2 cos squared u plus 2 cos u. We have negative 3 and negative 1 makes negative 4 is equal to 0. From here, we can divide everything by 2. And I hope you can see that this is very close to a quadratic, like x squared plus x minus 2 is equal to 0, which if you visualize it like this, it'll make it a lot easier to factorize, because now we need two numbers that multiply to negative 2 but add to positive 1. I can think of cos u, it's going to be plus 2 and minus 1. In case you're wondering why it's cos u, if we were to factorize this, we get x plus 2, x minus 1, which x would just be cosine. So we've factorized this, and it's still equal to 0. And as we did before, we're going to let each of the factors equal 0. Cos u equals negative 2. U, which was, if we go all the way back, u was x over 2. So cos of x over 2 equals negative 2. Negative 2. X over 2 equals cos inverse of negative 2. I believe this is going to be an error. We actually can't get that, but we'll leave that for now. And for this one, we get cos of x over 2 is equal to 1. X over 2 is equal to cos of inverse of 1. Now, if you try and type this into your calculator, it actually won't let you. So you can try it here. Let's see if it works. Cos inverse of negative 2 is a math error. So there's no solutions for this one. No solutions. So we'll leave this for now. And let's solve for this. X over 2 is equal to cos of 1. I believe we should get 0 and 2 pi. But since our domain, well, I specified in the beginning from 0 to 2 pi, since our domain is 0 to 2 pi, if you still solve for x, we get 0 and 4 pi. That is outside our domain. So our only solution for here is x is equal to 0. That's our only solution. And that's the end of that example there. Now that you've seen that, you can give this one a go yourself. So here we go. You can go ahead, pause it, and give it a go. Big hint is already here for you. So let's actually solve this now. So if we let u equal x over 2, we're going to get on the right hand side 2 tan of u. But on this left hand side, sorry, that should have been x, we get tan of 2u. Okay, so now let's use our trig identity for tan. Tan of 2u becomes 2 tan u over 1 minus tan squared u. Just following the identity there. And that is already slightly more easy than this original equation. Solving for this, let's get rid of this denominator by multiplying by it. So we get 2 tan u equals 2 tan u times 1 minus tan squared u. I can already see we have 2 tan u and 2 tan u. We can divide that out. So we get 1 is equal to just this, 1 minus tan squared u. Minusing the 1 from both sides, you get 0 is equal to negative tan squared u. Dividing by negative 1, just move this around. So tan squared u is equal to, well, 0 divided by negative 1 is 0. Tan u, taking the square root of both sides, square root of 0 is 0. But let's now bring back the original substitution that we did, x over 2. So we get tan x over 2 is equal to 0. X over 2 is equal to tan inverse of 0. And for this, we should get, well, if we just use our calculator, I believe shift tan of 0 is going to be 0 degrees. But also, we need to think about where sine is also 0. Because remember, tan is sine x over cos x. And if it's 0 over anything, it's also 0. So where else is sine 0? Well, sine is 0 if we use our unit circle. Sine is the y length, like so. So when sine is 0, there's 0 height. But also, when sine is 180, there's also 0 height because it doesn't move up or down. So it's actually also pi. Multiplying both sides by 2, we get x is equal to 0 and x is equal to 2 pi. And I believe those are our only two answers, 0 and 2 pi. So I hope you can see that using the double angle identities isn't so difficult. It's more the more difficult trig equations that we are solving. But I hope you can recall all your trig equation skills and methods. And yeah, hope I gave you an insight into how we might apply different trig identities to solve these equations. Hope to see you in the next video. Best of luck.